Good morning, everyone. This is Julian Rodriguez from DCL Geoenergia. We're a Spanish company, and we are experienced in the integration of renewable energy in buildings, mainly in hotels and wellness and spa project buildings. We have some experience too in building refurbishment and to integrate the renewable energy systems in those kinds of buildings. Uh, our main goal today is to show you and to talk about the chances and possibilities that geothermal energy has to the wellness and spa centers projects when it comes to savings of energy in high density energy demand buildings. We're going to start talking about the energy demand and use in buildings. Given the fact that the building sector is one of the more energy intensive in any human activities and any business activity. And given the fact that about 31% of final global energy demand is used in heating and cooling buildings, I'm pretty sure you are going to figure out that saving energy and um, global warming effect gas emissions reduction is one of the main goals nowadays and in the future for any building refurbishment and new buildings projects. Sustainable energy in buildings is a very hard to tackle challenge nowadays, and we have been working for years on that is a particular issue of our projects. The energy costs are also a factor, a quite important factor, by the way, when it comes to business based in buildings that use energy, because it can be one of the main spendings in those buildings and business. The thermal uses, namely heating water, removing the humidity of the areas with swimming pools and spa centers, heating all these areas is one of the main sources of spending. So savings on those particular aspects of that business is something that we can be quite useful with our technology, with particularly hard to tackle projects. Nowadays, the wellness centers are heavily based on water treatment and heating systems. Those buildings are also quite hard to heat and to keep their air at suitable comfort conditions. So their installations are usually very, very energy demanding, something that usually goes from 500 to 800 kilowatts hour per square meters yearly. The heating, ventilation, and air conditioning systems of those buildings are particularly powerful and energy demanding. Why? Because we need to treat the air. We need to use gas boiler, heat pumps, rooftop systems able to manage the air of those buildings. We need to keep the comfort in a high level for very demanding customers. And there are many technical installations and facilities that are used for that goal. Also, the cooling systems for ice rooms, thermal pools, and so on, used to spend lots of energy. So keeping working those systems and the maintenance issues that they used to demand are quite important in the monthly energy bills and maintenance bills of that business. Nowadays, in order to produce heat and cooling for that buildings, many technologies are being used, namely direct heating with electricity, the well-known Joule effect, diesel boilers, natural and propane gas boilers, and heat pumps. Of all those technologies, the most efficient one is the ground sour heat pump technology, which is able to produce hot water and cold water by extracting and exchanging heat with the earth itself. We're going to talk about that particular technology right now. Heat pumps, and particularly water-to-water heat pumps, use a cooling gas able to expand and evaporate and condense, exchanging heat with the surrounding air or with the earth itself. The way it works is that it extracts the heat from the air or from the earth, and when it compresses, it has to liberate that heat. We are nowadays able to achieve high performances with that technology. Just figure out, just picture that the more the hotter the air is outside, or the cooler the air is outside, the harder to extract heat from it or to dissipate the heat when it comes to work as a heat pump or as a cooling unit. If we are able to exchange heat with the earth, or with the underground water, that difference of temperature is quite easier to manage, because Earth is always at a steady temperature of about 16 to 18 degrees, so that the energy used to produce that heat and cool is about half of the used with air-to-water heat pumps. There are several ways to do that. We usually make drillings in the earth itself under the building, with closed loop systems, which consist on vertical or horizontal grids of pipes, and through which we make pass water. Open loop systems use underground water rather than exchanging the heat with the terrain. All of them have their advantages and their disadvantages. The closed loop system use great extensions of terrain when they are horizontal systems, and high investment when it comes to vertical systems, because we have to drill up to 150 meters, and we extract about 5 kilowatts each drilling. So a 300 square meter spa will need about 16 to 20 vertical drillings. When it comes to open loop systems, legal permits from environmental agencies are hard to obtain, and sometimes they directly deny those permits. Usually it takes about 18 months to obtain the permit to use the underground water. So our company has been working on those systems for years, and we recently developed a technology able to combine the advantages of both systems. We call it the DCL system, which stands for Dynamic Closed Loop Systems. What we do is that we make a drilling and we reach the underground water. Once we made the drilling, we introduce a heat exchanger, which exchanges heat with the underground water by extracting it from the bottom part of the drilling and re-injecting into the terrain itself in the same drilling. The closed loop circuit is the one the heat pump or cooling system uses to dissipate the heat or extract heat from the terrain. What we do is that we're able to obtain up to 80 kilowatts peak power from one single drilling. So the area needed and the investment necessary is up to 70% less than with conventional systems, thus making very easier to invest in a renewable system to reduce the carbon footprint of our buildings and wellness and spa centers, and to further make the payback period shorter. We are talking about payback periods of that investment of about 3 years. Wow. Our renewable system has been proved, and it's working in several buildings in Spain and other countries, and we have been able to power agricultural installations, hotels, swimming pools, office centers, and single-family houses. It's a well-proven technology, and we have the experience to tackle harder projects in new buildings and buildings that are going to undergo a refurbishment. installation-intensive buildings like wellness and spa centers used to make a very intensive use of energy because they need to heat water for hot water uses, hot swimming pools. They need to remove the moisture, the humidity of the air with cooling systems, and so on. So they are one of the more advantage-prone kind of buildings to our technology, because with one single system, with one or several heat pumps, we're able to produce hot water at different temperatures and cool water able to power all the systems. And we are able to dissipate or extract the heat from the terrain with our DCL system, um, by combining the performance of heating water and cooling water with the same facility. Many examples of it, and without need of going to very nerdy technical issues, I'm going to save you all of that, is that we can power the whole building with a couple or just one hot heat pump, able to produce the hot water, heating the swimming pools, um, powering the heating and ventilation systems, and even cooling system from ice rooms, cool swimming pools, and even the conservation chambers of kitchens or hotels, all with just one system. Nowadays, we can integrate that technology even in existing buildings, because the space we usually will need with a conventional geothermal system has been very reduced with our technology. One example is that, as I said before, a 300 square meters wellness spa centers will need an investment of under 100,000 euros, so excuse me, dollars, to install one single heat pump and chiller, make a couple drillings, and integrating into the existing heating and cooling systems. Even that we are able to further integrate it when it comes to renew all that systems in the building. We have some examples in many hotels and swimming in spa centers in which we have registered a good success in terms of economical savings and energy reduction. Uh, Moreover, we can reduce the carbon footprints. And when it comes to quality seals that are being used in Europe and in the USA too, and South America, we can certify that carbon footprint reductions with our system, which can further improve the perceived quality for customers of that kind of business. These are some of our examples in which we are being able to heat in the water for showers. We can heat the swimming pools. We can cool the water that powers the cooling system for the building, and so on. When it comes to figures, one of our examples we are very proud about is the Boramar Hotel in Benicassim. These are real figures. So in one of the years it has been working, we have been able to combine the supply of hot water, heating and cooling for the building with a reduced demand of electricity. This building has received some awards in carbon footprint reduction and renewable energy use, and it has been able to install a PV system in a very reduced space in the rooftop, able to power the geothermal system. With just 2 heat pumps, we have been able to provide the building with heating, cooling, conservation chambers, cooling, hot water, and so on. And we have been able to replace the existing cooling systems and gas boilers. The combined seasonal performance factor has been of 5.7, which is a very outstanding figure. We achieved that by combining the production of heating and cooling with just one system. The payback period has been of just 3 years for the investment, and Moreover, we have been able to install a geothermal system with just 5 drillings. With the conventional closed-loop systems, we will need about 26 to 27 drillings, and the hotel hasn't the necessary area to make that. So we can go with this technology where the conventional technologies are unable to go. Hopefully, you find interesting our explanation, and I'll be very glad to answer any question you have for me. Thank you so much.
Thank you, Julian. Does anyone have questions here?
That was great.
Yes?
Julian, I've got
just a quick question, I guess, with regard to mechanical space, assuming if it's a retrofit or a new construction.
Yes.
Is there an estimation as to how much additional mechanical space is needed to accommodate everything? Is it an additional 10% or 20%, or is it a net zero because of the equipment that you say can be replaced with this?
Yes, that's a good question. I like it, and hopefully you like the answer. In this particular project, if you want a real example, we needed just about 3 by 4 meters technical room with 2 floors. So we could talk about 8 by 3 meters technical room, in which we needed to house the 2 heat pumps, the circulating pumps, the water tanks, and all the piping and power board system. Usually, we can reduce the needed space when it comes to building refurbishment because, as you sure know, boilers are very space demanding. We need very big technical rooms for fume extraction systems, pumps, etc. Many heat pumps are able to combine the production of heating and cooling with circulating pumps being integrated into the heat pump. So the area is usually smaller than with conventional systems. Just picture a technical room with 2 boilers, because usually they are doubled for safety and security of heat production issues. We need to install in the rooftop the external units of chillers, and we need to double the amount of circulating pumps. So we usually are able to reduce in about 30% the mechanical area needed for that systems. When it comes to refurbished buildings, if we are talking about new buildings, that space requirement is usually further reduced because we can install a more powerful heat pump or chiller in a more reduced area. And we, as I said, and I'm sure you guessed, the external units disappear with the systems. That means that we're liberating the rooftops of any solar panel, thermal solar panel, external units, chimneys, and so on.
Okay, thank you.
Thank you so much. I would like to say, to give you some time to think about questions, is that another thing that we have been able in our experience to reduce our maintenance cost, because we can ditch the use of machinery and equipment which is exposed to the external ambient. You know, a good example are coastal hotels. The air always has some salt and some chlorides, which are quite aggressive with metallic parts. So, as you know, external units of chillers used to rust and to experience salt depositions and so on, and they have to be replaced each 8 or 10 years. we have been working and making maintenance in geothermal systems that have been working for 30 years without no further issue that making the usual maintenance to the chillers. Because as long as not a single machinery piece or equipment is exposed to the weather, shelf life, its useful life, it's usually doubled of even treble from the usual, so that maintenance costs are very lower. And the safety issues with evaporation towers, condensing towers, about legionellosis and public health issues are avoided with this system, with always avoids those typical public health concerns of local governments and councils. A good example has been here in Spain, in a city, a coastal city, which is named Alcoy, which has been many issues with legionellosis, with Legionella. I'm not sure if it's the name in English, I'm sorry. So we have been able to replace external systems that were prone to generate risks related to legionellosis with geothermal systems. It's a side effect, a positive side effect of this technology.
Is there any recommendation for redundancy in extreme climates? For example, like in the Middle East or maybe in Scandinavia where you have extreme cold or extreme heat?
Yes. I'll answer the both questions separately. When it comes to extreme cooler climates, as you know, usually where the need for heating is going to be quite higher than the need for cooling. So the peak power of the underground system has to be closer to the maximum heating power needed. The underground water, it's usually found at a bigger depth, so the investment can be about 15%, 10 to 15% higher. But as we work with water which is in the underground, we don't need to go to temperatures below zero in the brine system, so that propylene glycol anti-freezing additives are not used, are not needed. When it comes to extreme heat climate, it's the opposite. But anyways, there is an advantage for both different scenarios, and it's that the water temperature and the ground temperature is steady all year round, so that the performance is far better than with air to water heat pumps. What means that as we don't need to exchange heat with air which is about 40 degrees Celsius, I'm not sure which temperature is that in Fahrenheit, I'm sorry, but picture out Middle East. And when it comes to systems that need to extract heat from air, which is below 0 degrees, picture out, Northern Europe, those systems and the refrigerating gas are usually more extreme, more powerful, and more expensive. And we teach the need to go to extreme temperatures in our systems, because we can work always with temperatures over 0 degrees in the water systems. That means that the saving in electricity and energy to produce the cool and the heat is bigger than in template climates, as in Spain, in the Mediterranean basin. Hopefully it answered your question.
I think so. I guess one more question in terms of all of the pumps and the equipment that is utilized. Is everything already like UL and CL approved for use in the United States and North America?
No, we haven't been lucky to make one of our system in the USA. We have been working in Spain, in Portugal, in Malta, and in Europe nowadays, and we have been working in South America, in Mexico, mainly in Mexico. Anyways, we have a very large experience in different kind of terrains when it comes to drilling and making it work in limestone terrains, in coastal terrains with layers of gravel and sand, in terrains with clay, and our experience allows us to tackle different challenges with different terrains.
But in terms of the equipment internal, the pumps and everything, yes, all the electrical equipment,
yes,
has that been certified and approved to be utilized in the US, or is that still pending certification?
I think that we are going to receive the qualification of the patent in the USA about in the first quarter of 2019. We have received all the qualifications and all the permits for our patent in Europe. But when it comes to go overseas, you know, it's a little longer to obtain. Anyways, as our development and research department has been working on it since 2013. Well, the last thing I have is that we are expected to have all the certification and patents in the USA in the first quarter of next year, in a couple months,
okay,
more or less.
Great. Thank you.
Thank you so much.
Any other questions for Julian? Great. Well, thank you very much, Julian, for joining us today. This has been a wealth of information for all of our consultants to be able to use and call on you for. So thank you very much.
Always a pleasure. My contact details, by the way, are here on the last slide, and I'm sure Michelle is going to provide you with any information about our company or how to contact to us. We'll be very happy to answer any question by email or by phone, and to send you any information and making any study about your projects if you need it. So thank you so much for an attention, and you can find me in that email address, and I'm gladly inviting you to visit our webpage. Thank you very much for your attention.
Wonderful. Thank you.
Thank you.
Have a great day, everybody.
Thank you.
Thanks very much.